Hi, today we're going to look at base E and natural logarithms. But before we do that, let's take a look at regular log. So sometimes you may see log with no base there. What that really says is we have log base 10 of a number. That base 10 is like a default number. It's there, you don't have to show it. It's like that magic one where you can turn any number into a fraction by putting it over one. In front of every variable, with there's no number, there's a one, and every exponent, if you don't see one, there's a one. So that's that magic 10. Now, sometimes that number might be something different. We might have something like log of E. What that base E is, it's this new special number, kind of like pi, kind of like I, but it does have a value of 2.718 something something something. It goes on forever and ever and ever. We call this E a natural base. So if we have a problem with a natural base in it, we can rewrite it. Anything that says log E of something can be rewritten as ln 3 equals x. So instead of saying log of E, we can just interchange that with ln. Okay, now with all this, we can use this property or this thought process and kind of rewrite things like we did over here to put it in exponential form. When we do that, we take that E, we push it over, and we're left with e to the x equals 3. Now, why is this important? Well, we can go straight from here to here, and we're going to go from there back to there. Sometimes, though, we need to stop in the middle. So we're going to look at how do we rewrite from exponential to log, or to natural log rather, and natural log to exponential. So let's take a look up here. So here we have e to the x power equals 7. I'm starting here. I want to work my way back, but in the meantime, we got to stop here in the middle. Okay, so we're going to have a new problem that says log of E. That's the goal. So E comes down just like we did down here. The number next to the log is going to be what's left over at the end, which is going to be 7. And then we equal our variable of x. Why is this important? Because when we take it one more step further, instead of writing log E, we have a simplified version of just ln 7 equals x. Same thing happens if we happen to have a variable down here. It's no big difference. We want to go and say log E. Next to this is going to be a number off to the end equals, and that exponent comes down, and that's your answer. Now to switch that over to a natural log, whenever you see a log base E instead of a 10 or anything else, that log E changes to natural log, and we write our x equals 5. No difference there. Okay, now going from natural log to exponent. So I'm starting here. I want to end here with just E. So let's go backwards. Instead of natural log, we can rewrite this and say log E 8 equals x. And then we can use our properties that we learned simplifying logs, going from log to exponential, and the same rules apply. We're going to move the e over. We're left with 8 equals, and then e to the x power. That e pushes that x up in the air. Okay, now over here last. So this one looks a little different because now we're starting off with a variable here, but then we have these squiggle little equal signs here. That means approximately. While working backwards, especially with this exponent, this decimal goes on and on and on and on and on. It's not going to be an exact answer. So we use approximate just to say that it's not perfect. So let's work backwards from here. Instead of ln, let's say log base E of x is about 0.7741. Let's move things around. X comes down, we say about e to the 0.7741. So it's not really a huge difference. It just makes it look a little more complicated when it happens to be you're moving everything the same way. So, and that's base E and natural logarithms.